Hello, everyone. What I want to do is go over homework 3. So, yeah, for the most part, well, actually, I didn't grade these yet. I will grade them soon. Another thing to attend to after this review session for something for doctoral students, and then I will get to grading this. So I don't have no idea how you guys did. I'm sure most of you did fine. Okay, so 100, deposit 100 now, another 100 at the end of 15 years. Count earns nominal discount of 6% daily for the first 15 years. Nominal discount rate of the 52, a little redundant here, compounded weekly, because 52 means weekly. If you have 950 at the end of 45 years, figure out what D52 is. Okay, so let's first convert daily discount into the equivalent effective annual interest rate, right? So you always want to remember, it doesn't matter if we have nominal interest, nominal discount, year, whatever. They're all different ways of describing the same kind of growth, right? So given D365 is 6%, what yearly growth does that correspond to? Let's figure out. And we know it's going to be roughly 6%. All these numbers are roughly the same. So as we've done in examples, we first go to D. Just plop into my formula. As we'll see in a little bit, we can do this on the calculator very, very quickly. But it's still good to understand formulas. So plop this in the calculator, 0.05824. And next, I is D over 1 minus D. Plop this into the calculator, 0.06184. So here is the situation. Draw a time diagram, makes life so much easier. So just 2 deposits now and at the end of 15 years. All right, so we know what I is for the first 15 years. It's 6.184%. We just computed that. So to me, the easiest thing to do is figure out what I is and then convert it to D, then convert it to D52. Okay. So yeah, 100, 100. So we got 950, the accumulated value. So there's 100 earns 15 years at 15 years of interest and an interest rate of 6.184%, an annual interest rate of that. So it's 100, 1.06184 to the 15. Then it's 1 plus I. This is 30 years. Sorry. So it's going to be 30 years. That's trying to find this stupid eraser. Oh yeah. Right. So it's fine. 30. Okay, and then we have 100. This is going to be 30 years, 15 to 45. Yeah. I have this 25 written down on my solution sheet for some silly reason. All right, but you factor out 100, factor out rather 1.1 plus I to the 30th. I'll factor it out here. Bust out my calculator in a second. So this here is going to be 3, 4, 5, 9, 7, 8, 5, 1. So calculator here. So 950 over 3, 4, 5, 9, 7, 8, 5, 1. Raised to the 1 over 30. So you get I 0.034. So these two are equal. Uh, 2427. All right, so D is 1 minus 1 over 1 plus I. So add 1. 1 over minus plus 1. Yeah, little smaller than I. So it should be close, as I always say. So 0.033, 109. All right, and D 52 is 52. 1 minus this number here, 0.003, sorry, 0.033109. 1 over 52. So let's see what that is. So minus plus 1. Raise this to the 1 over 52. Nice small number. It's really small, but times 52.033 659. 3.3659%. Okay, yeah, number 2. Here's my force of interest. Positive 200 is made, t equals 0. X is made, t equals 3. 350 is in the account, t equals 5. So really, so you can do this one of two ways. I guess I'll do this both ways. So really, yeah, actually, I'd probably, well, let's see. I'll think about doing it both ways. So yeah, let's see what the 200 does at the end, f from 0 to 5. So it's 200 e to the integral 0 to 5 force of interest dt. The positive x is made at t equals 3, so it's x e to the integral 0 to 3. Sorry, 3 to 5. Because we're trying to figure out what we're trying to get what's going on at t equals 5. So it's from t equals 3 to t equals 5. That's what x grows to. So easy stuff here. 200. So 0 to 2.02t. 2 to 5. So this whole thing plus x So 3 to 5 is just 0.00. Three t squared. All right, so this is just t squared over 2. So 0.01 t squared. Plug in 2, plug in 0. 0.001 t cubed, plug in 2, plug in 5. Again, 0.001 t cubed, plug in 3, plug in 5. Probably just check my answer here. So 2 squared is 4 times 0.01. So here this is going to be plus 125 times 0.001 minus 248. 0.08. So 0.157. Trying to find the exponential function here. What is this stupid thing? Sorry. Here we go. So 233 99912 and x e the point sorry, this is 5 here, not sure what happened there. So there it's 125, 5 cubed. And there it's 27. So raise that to the e. 1.10296. All right, so these are equal. Solve for x. Easy peasy. That looks a little weird. I have an x. Yeah, so x 105 17. Okay, yeah, if you want to do it the other way, it's a little more cumbersome, but that's fine. So just do it after 3 years. Another AV, accumulate value. And this is before X deposit. So simply it's 200 e to the integral 0 to 3. So just like before, 0 to 2, the first one. Plus 2, here's 2 to 3. All right, so 200.01 So just like before, it's 0.01 t squared, 0 to 2, so it's 0.04. Sorry, 0.003. Got ahead of myself there. 0.001. T cubed from 2 to 3. So yeah, that's again 2 squared is 4.04 plus 0.001 times 27, 3 cubed, minus 0.001 times 8, 2 cubed. All right. So it's 200 e to the 0.059. So 212, 155, 048. Right. Okay, so my total AV is 350. So after the X deposit, we have 212, 155,048 plus X. Well, this is going to earn 2 years of interest from 3 to 5. Point 003 t squared. Yeah, so there's definitely a longer way to do this, but it's fine if you want to do this way. 0.001. 125 minus 3 cubed is 27. Okay, so yeah, you do it like this. 0.001 times, or you could just do 125 minus 27. Doesn't matter. Minus 0.001 times 27. Second E. Now, that's what this is here. So I want to divide 350 by this. So do 1 over times 50 minus the 212, 155,048. 48. Now we get the same answer, 105.17. Okay, number 3, this is really very easy problem. So there's only so many kind of interesting compute the actual accumulation function type problems I can give you without resorting to crazier integration. And as I promised, and I've kept that promise for ever since I've been teaching this course, I'm not going to give you crazy integration. U sub is the worst I'm going to give you. So yeah, generic formula. So it's 100. Do this nice and quickly. And if you want to use a dummy variable here, I don't care. It's up to you. Doesn't matter. Technically, mathematically, I should use a dummy variable, but whatever. And all these problems are kind of the same. So the obvious U sub 1 plus I t to the 5th. And yeah, since I'm not testing you in this course that you know your integration, I make the du exactly. Yeah, I make the du exactly be what it needs to be. So this is really nice and easy. So this is going to be 100 e to the integral, just du over u. When t is 0, this is 1. T, we'll just plug in t, then it's just 1 plus I t to the 5th. Right, so 100 e to the, so I is positive, so no need for absolute values. Ln of the top minus ln of the bottom. Ln of 1 is 0, so it's just 100. En does the ln. So easy peasy, 1 plus I t to the 5th. All right, number 4. Pretty easy one here. So the force of interest for Fund A is 3KT. Fund B earns nominal interest of 4% weekly. 100 is deposited in both funds initially. Find K if they both have the same cumulative value when T equals 3. So in other words, K is a constant. So yeah, let's get Fund B first. Doesn't matter what I do first, really. But I can get a number here, so I guess why not? So just plug and chug into your formula, 0.04 over 52. So this is 0.04079. Leave it at that. I wrote down a few more decimals, doesn't matter. So after 3 years, the accumulated value 1.0407948.3. And I don't care how you round, actually, just to be consistent, I'll just chop these off. Matter, be curious to see how much off I am. The answer I have. Right, so 1.04079. 112.74. 293. All right, so Fund B, sorry, Fund A, just plug and chug. Nice easy integration, 3KT. So it's just 3KT squared over 2. 0 to 3, so it's gonna be 927. Yeah, 3 squared times 3 is 27. All right, so bottom line is the 112.74293. What I have here is going to be equal to 100 e to 27 k over 2. So divide by 100 ln times 2 over 27. To get a little strange here. I'll try that again. 112,74243 over 100. All right, so ln this times 2 over 27. So K is 0.00888. All right, so just check times 27 over 2 raised to the E times 100, 112.74. So it checks out. Okay, last but not least, figure out how much is 2 days. Figure out how much is in the account 2 days after 3 years using 2 different ways. We're given the force of interest, so let's do the approximation method. So relative rate of change over this 2-day period is roughly we'll plug in 3, so it's 0.01 times 3. So what does that mean? Percentage growth over 2 days is approximately my relative rate of change. Remember, this is per year. So what's 2 days in years? Well, 2 over 365. And if you want it as a percentage, doesn't really matter because we'll have to convert it anyway. So it's 0.06. Convert to decimal afterwards. So 0.016438%. So we're growing by 0.016438% over 2 days. So tiny bit of growth, but it is 2 days. But yeah, you look at values like 10 million, that's still not nothing over 2 days. 0.0016438. Well, that's just simply 10 million 643 80 cents. Okay, method 2, the exact method. I'm always amazed at how these problems answer is so close. I mean, relative to a year, 2 days is a tiny, tiny, tiny time change or time interval, so it better be. Because the force of interest is the instantaneous relative rate of change. So we have a tiny time period, so the instantaneous relative rate of change should approximate the 2-day relative rate of change pretty darn well, and it does. All right, so this is going to be 10 million. I gotta hurry up here because I gotta get to my other review thing. So it's t squared over 2.005 t squared. Plug in 3 plus 2 over and plug in 3. Let's just see what that is. 3 plus 2 over 365. So is that squared? Probably easier to do -9, 3 squared times 0.005. Raise it to the E times one too many. Yeah, so 10,000,1,645 47. So we're off by a dollar, like $1.50 almost, $1.60. Yeah, so we're off by $1.60. That is really, really accurate relative to $10 million. Okay, yeah, any questions, let me know. Good luck on the exam, so take care and bye-bye. If you have any exam questions, I may or may not be able to answer them, depending on, if it's just clarify the meaning of this problem, I can. If it's how do I do this, I can't. Just remember, for the exam, we've done examples similar to everything.